Good morning, students. Today we are going to start, as we are starting of the session, I'm going to start chapter 4th. It's a really very easy chapter and it consists only one exercise. Chapter 4 is Principle of Mathematical Induction. Okay, so this consists only one exercise and based on a particular way to solve the questions. Okay, so what is that? It is Principle of Mathematical Induction. Also we write it as PMI. We write it as PMI. PMI is your Principle of Mathematical Induction. Means it's a different kind of maths technique to solve the question, in which one mathematical statement will be given and you have to prove it by using mathematical induction. Induction means how to solve the question. Each question will be solved by using two steps. Like this, whatever statement is given, the statement is true for n equal 1. Means what? P1 is true. I will be giving you example how we are going to solve it, but all question will be solved by these two steps. One statement will be given, Pn. Let Pn our given mathematical statement. So n is what? N belongs to n, means n is a natural number. Okay, the statement is true for n equal 1, means what? It means P1 is true. First step will be coming in each question, that the statement is true for n equal 1. Then we'll assume that our given mathematical statement is true for n equal k. N equal k. Then if it is true for n equal k, then statement must be true for k plus 1. Okay, and if it is true for k plus 1, when it is true for k plus 1? Whenever n equal k is true. So we'll say our mathematical statement is true. These two steps, how we are going to use in the question, I'm going showing you by the given questions. Okay, 2-3 questions I'm taking you, that will be help you to solve the whole exercise. If some doubts are there, I will be sending you in written also, but whatever two steps are there, the statement should be true for n equal 1. Then we will assume that statement is true for n equal k, and whenever it is true for k, it should be true for k plus 1, and k is also a natural number, or we can say a positive integer. See now what is the question given in your NCERT. This question number 5th, it is there. This is the mathematical statement given. This is what kind of mathematical statement, and it is given. Now we need to truth of this statement. How we have to prove it by using PMI. Always it will be written in the question that using PMI you prove this one. So first I will be saying the statement should be true for n equal 1. We will say for n equal 1. So I will be taking left hand side and I will be taking right hand side. Okay, so left hand side, this is n equal 1 means first term. First term is 1 dot 3, means 1 is multiplied with 3. This is equal to 3. That is your n equal 1. Now right hand side, I need to put what? N equal 1. For n equal 1, so I am going to put here n equal 1. So you are saying 2 into 1 minus 1, that is 3 raised to power 1 plus 1 plus 3 by 4. So you are going to solve it. What it is? 2 minus 1, 1. 3 raised to power what? Square means what? 9. 9 plus 3 by 4 means what? 12 by 4. 4 3 are 12. You see, left hand side equal right hand side. So what that? Left hand side is equal right hand side. So I will say Pn is true for n equal 1. Pn is true for n equal 1, or you say it means P1 is true. P1 is true. Means first step. What was the first step? The statement should be true for n equal 1. So I proved the question. The statement is true for n equal. Now let us assume. Let us assume that what? The statement is true for n equal k. Means what? Pk is true. We will assume it. Pk is true means I will be using, instead of n, I will be writing k. So it will be your 1.3 plus 2.3 square plus 3 multiplied by 3 cube plus n. I will be taking n equal k. So instead of n, this k, 3k, it should be equal to 2k minus 1. Wherever n is there, I am writing k. 3 raised to power k plus 1 plus 3 by what? It is your 4. Okay, this is true. Let this equation is 1. Now truth of this will be helping us to prove it for n equal k plus 1. So I need to prove that statement should be true for n equal k plus 1. So I will be writing k plus 1. What it should be? Your series will be 1.3 plus 2.3 square 3 cube plus what that it is k. I will be taking it k dot 3 k. So obviously this series is for k. So next coming integer will be k plus 1. So I will be writing, instead of k I will be writing k plus 1 dot 3 k plus 1, because I am checking for this should be true for k plus 1. So this series was given up to k terms. I am taking next integer k plus 1, and here wherever n is given I am going to write k plus 1. So be careful while solving this one, because student make mistake. So 2 bracket I will be writing k plus 1 minus 1. Then what is your 3? Instead of n, k plus 1 plus 1. Okay, plus 3 divided by 4. Okay, so I will be writing it. What I need to prove it? 1 dot 3 plus 2 dot 3 square plus 3 dot 3 cube plus k dot 3k plus k plus 1 dot 3k plus 1 equal what I need to prove, that you simplify it, that it is your 2k plus 2 minus 1. So it will be 2k plus 2 minus 1, 2k plus 1. What it is your 3k plus 2 plus 3, this is 2 divided by 4. I need to prove this one. So to prove I will be taking left hand side. I will be taking left hand side, and I will use what? Use equation 1 in left hand side. Equation k 3k, sum of till here to 3k, already I said it is true, so I can use this term. Till here I can use this term, so I will be writing value what? 2k minus 1 power 3k plus 1 plus 3 by 4. That is, already I said this statement is true for n equal k, means up to this series I can use, because this part is equal to this, so I have substitute here. Plus what is given here? K plus 1 dot 3k plus 1. Got it or not this one? Now I have taken left hand side, and I need to prove that this left hand side is coming equal to this. So this part should come equal to this. So I will be taking, how it will be coming? See, equal, take LCM. Take LCM means what? 2k minus 1, 3 raised to power k plus 1 plus 3 plus 4 k plus 1 dot 3 k plus 1 divided by 4. Now separate this 3 term alone, and you can see this one from this term, and from this term common is 3k plus 1. So I am taking 3k plus 1 out. This 3 separate, okay, only this term and this term I am taking common 3k plus 1. So bracket it will come 2k minus 1. Okay, 2k minus 1, and here if you are taking this 3k means inside it is 4k plus 4. Okay, plus 3 by what it is your 4. Okay, so now you solve it is 3k plus 1, 2k plus 4k, what it is your 6k, what it is your plus 3 divided by what is your 4. Okay, that it is coming yours. Now listen how to solve this one. You are going to take this term I am writing here. Okay, what you have got? You have got 3k plus 1. Okay, bracket it is coming 6k plus 3 plus what it is your 3 by what is your 4. Okay, so you are going to take common from this one. 3 is common. So listen carefully. 3k plus 1 dot 3. Inside will be what? Your 2k plus 1 plus 3 by 4. And you know exponential rule, 3 raised to power k plus 1 और ये 3 का पावर 1 है, तो पावर्स विल बी एडिड. तो ये बन जाएगा 3 की पावर k plus 2 inside 2k plus 1 plus 3 by 4, which is your what? Which is nothing else but here what we were supposed to prove, 2k plus 1, 3k plus 2 plus 3 by 4. It's same right hand side. It is equal to right hand side. Okay, so what? Our Pn is true. Pn is true. Okay, for means our given mathematical statement is true. Okay, so or one more line you can say that pk plus 1 is true whenever pk is true. Pk is true means you got how many statement? 2 statements is there. First for k equal 1 you are going to prove, means p1 is true. Second is you are assuming that pk is true. Then you need to prove using this pk is true, mind pk plus 1 should be true whenever pk is true. Then we prove that our statement is true for n belongs to n, means n is a natural number. One more question I am taking you, a different question is there. That is what? it is in the form of inequality. Less than sign is given, means it is not equal to. So whenever inequality is given, there is one different rule to solve. The first term will be same only, just you need to do for what we are going to do for n equal 1. N equal 1, I will be taking left hand side. Left hand side is what? Your left hand side is giving 1, and right hand side if you are putting is what? 1 by 8. N equal 1 you are going to put, to n equal 1 means 2 plus 1 square, so it is coming what? Your it is coming equal to 9 by 8. And you know what, that your 9 by 8 is a mixed fraction, so 1 by 8. So always 1 is lesser than 1 by 8, means this is greater, this part is greater than this one, so our P1 is true. What is that? Your mind, this statement is true. Okay, first we have proved. Now second you know, that is we will assume that it is true for Pn is true for n equal k. It is true for n equal k, means I will be saying this, means 1 plus 2 plus 3 sum of n natural number, and instead of n I am going to take k, is what? 1 by 8. What it is? Your 2k plus 1 whole square. This is our equation first. This is true. Okay, now I need to prove for n equal k plus 1. Whenever this is true, this is I assume this is let for any n equal k. कोई रैंडम नेचुरल नंबर है, मतलब मैंने सपोज 6 तक ले लिया या 7 तक ले लिया, दिस स्टेटमेंट इज ट्रू. अब मुझे उसकी नेक्स्ट इंटीजर के लिए, नेक्स्ट नेचुरल नंबर के लिए प्रूव करना है, तो आई नीड टू प्रूव फॉर n इक्वल k प्लस 1. अगर ये ट्रू होगा तो मीन्स गिवन जो मैथमेटिकल स्टेटमेंट है वो ट्रू होगा. दिस इज कॉल्ड इंडक्शन. अगर ये 5 टर्म्स के लिए ट्रू है तो 6 टर्म आई प्रूव्ड. इफ इट इज ट्रू फॉर 5 टर्म्स तो 6 टर्म के लिए भी ट्रू होना चाहिए. दैट इज कॉल्ड इंडक्शन. ओके, first I proved it for P1 is true, then I am proving it what, that your for n equal k let it be true. Yes, I assume it is true. Now I am proving for n equal k plus 1, means I need to prove what? 1 plus 2 plus 3 plus k. Next will be coming, next natural number will be coming k plus 1. Okay, now it should be what? Your 1 by 8, and k, instead of k I am writing k plus 1. तो ये कितना हो जाएगा आपका? You will be writing like 2 bracket में k plus 1 whole square, means I need to prove actually what? 1 plus 2 plus 3 plus k plus 1. It should be what? Your 1 by 8, and it will come, listen, 2k plus 2 plus 1, 2k plus 3 whole square. It should come. This I need to prove. अब इसको लेफ्ट हैंड साइड सेपरेटली नहीं ले सकते, बिकॉज आई डोंट हैव हेयर इक्वल साइन. I can't substitute value here. We can't substitute because ये equal नहीं है, एक inequality है. तो इसको prove करने के लिए I need to use this one because this is true. तो I will be taking what? I will be adding both the side in equation 1 k plus 1. I will be adding here because I can't substitute here क्योंकि ये equal sign like previous question. तो but this is true. तो I am going to take help of equation 1 by adding both the side k plus 1. क्योंकि जब भी कोई इनइक्वलिटी लाइक सपोज 6 इज लेस देन 10, और अगर मैंने दोनों साइड 2 ऐड कर दिया बाय एडिंग 2 बोथ द साइड, तो आपका ये 8 इज लेस देन 12 वो रिमेन रहेगा, ट्रू रहेगी, इनइक्वलिटी विल बी ट्रू. तो आई एम गोइंग टू ऐड k plus 1, ऐड k plus 1 both sides in equation first. So you are going to what it will be converting into 1 plus 2 plus 3 plus k plus 1 less than 1 by 8. What it is? Your 2k plus 1 whole square plus what I added k plus 1. Okay, I can add same. This will remain same. So now this is mine. What I need to prove, it is coming to there only. So it will be your k plus 1 less than 1 by 8. What it is? Your 2k plus 1 whole square. So you are going to take LCM here. So it will be your 2k plus 1 whole square plus you are going to write what? That your 8k plus 1 by 8 I can write it. Okay, or you can one more step I will be showing you how we are going to solve. It is your plus k plus 1 less than 1 by 8. You take common and you solve this one. What it will be? Your 4k square plus what it is? Yours 1 plus 4k and plus what is your 8k plus 8. Got or not? I have taken what? That your LCM means 8 I multiplied 1 by 8 common and I solved this one. So one more step we will be writing here. What it is coming, 1 plus 2, 3 plus what is your plus k, plus what is k plus 1, and it is 1 by whole common, and you are going to solve it is 4k square plus what is your 12k, correct or not, plus what it is your 9. Now this, you know, this is nothing else but the perfect square of what, 2k plus 3 का whole square. और ये सीरीज ऐसे ही है, 1 plus 2 plus 3 plus k plus 1. And you will see this is nothing else what I was needed to prove for n equal k plus 1. This expression is less than, so what that your this is true for k plus 1. So pk plus 1 is true. We will write always pk plus 1 is true whenever pk is true, because I took help from when n equal k, pk is true. So now what I conclude, that my mathematical statement Pn is whatever given in the question is true. This is my answer. These are the fixed steps to solve the question. Okay, first for n equal 1. So you can solve up to I think 15 question, one different pattern that I will be discussing afterwards. Thank you students.